Hi guys, welcome to my channel. Before we get started, make sure to hit that like button and also subscribe to my channel. Quantum computing, how will it revolutionize the internet? So make sure to watch the full video. Quantum computers, according to some, may either destroy the internet, making all data security protocols useless, or help us compute our way out of the climate issue. There's a lot of talk surrounding these super powerful gadgets, a new technology that makes use of quantum mechanics. A new 433 qubit processor that is 3 times more powerful than its predecessor, constructed only in 2021, is the most recent quantum computer from IBM. It was introduced in November of last year. What, though, is the big deal? A branch of study known as quantum explores the physical characteristics of the natural world on an atomic and subatomic scale. According to proponents of quantum technology, these devices could lead to rapid advancements in areas like materials science and drug discovery. This prospect raises the tantalizing possibility of producing materials that could effectively capture CO2 or lighter, more efficient electric vehicle batteries, for example. Technology that offers a chance to resolve difficult problems is sure to spark intense interest as the climate crisis looms. Therefore, it should come as no surprise that some of the biggest tech companies in the world, including IBM, Google, Microsoft, and Amazon, are investing substantially in it. How are quantum computers operated? It might be helpful to understand how these futuristic-sounding devices operate and what sets them apart from traditional computing, given the fervent interest they are receiving. Consider every gadget we have at the moment, from the smartphones in our pockets to the most potent supercomputers. The same binary code theory underlies how these work and have always worked. Our computers' processors essentially use tiny transistors that act as on/off switches to produce binary digits, or bits, which can only have 2 possible values, 0 or 1. Bits are short for binary digits. These bits can be organized into larger, more intricate units, which are simply long strings of zeros, and once encoded with data commands that instruct the computer what to do, such as display a movie, show a Facebook post, play an up3, allow you to send an email, and so on. A quantum computer, however, these gadgets operate fundamentally differently. The fundamental piece of information in quantum computing, referred to as a quantum bit or qubit, replaces bits in a classical computer. Usually these are subatomic elements like photons or electrons. The capacity to control these qubits is the key to a quantum machine's high level of processing power. Ivano Tavernelli, the IBM Research Lab's global leader for advanced algorithms for quantum simulations, explained the concept of a qubit to Euronews Next. A qubit is a 2-level quantum system that allows you to store quantum information, he said. We can create a superposition of these 2 states rather of just the 2 levels 0 and 1 that would be present in a classical computation, he continued. Superposition. In contrast to a binary system, which can only have 2 possible values, 0 or 1, a qubit in superposition can have either a value of 0 or 1 or both 0 and 1. And if you still find it difficult to understand, the analogy of a penny is frequently used. An unmoving penny has 2 faces, either heads or tails. But what if you turn it up until it hits, and you can measure it? It's kind of like a coin toss, where heads and tails are both possible. And because you may be in numerous states simultaneously, you have an exponentially larger number of states to encode data, which makes quantum computers exponentially more powerful than conventional binary code computers. Quantized entanglement. Entanglement is another quality that is essential to the operation of quantum computing. Even Einstein in his day was perplexed by this somewhat enigmatic aspect of quantum mechanics, referring to it as spooky action at a distance. Simulating the physical world will be considerably simpler thanks to the quantum computer. IBM Research Lab Director in Zurich, Alessandro Curioni. No matter how far apart 2 qubits are from one another, when they are formed in an entangled state, there is a direct, measurably correlated relationship between what occurs to one qubit and what happens to the other. In the traditional world, there is nothing like this phenomenon. This entanglement characteristic is crucial because it creates a much stronger link between the various units and qubits. Thus, Alessandro Curioni, the head of the IBM Research Lab in Zurich, told Euronews Next, this system's elaboration power is stronger and better than the classical computer. In fact, Alain Aspect, John Clauser, and Anton Zeilinger were the 3 researchers that shared the Physics Nobel Prize this year, for their work on entanglement experiments and the development of quantum information. What is the purpose of quantum computers? These are the fundamental components of quantum computation, to put it succinctly and admittedly simplified. However, with supercomputers already available, why do we really need such incredibly powerful machines? He said that the simulation of the physical world will be made significantly simpler by a quantum computer. A quantum computer will be able to model the quantum environment more accurately, including simulations of atoms and molecules. This, according to Curioni, will enable quantum computers to assist in the creation and discovery of novel materials with specialized features. The issue of mobility can be resolved if I can create a better material for energy storage. I could end world hunger and increase food production if I could create a better fertilizer. I can stop climate change if I can create a brand new substance that enables us to capture CO2, he declared. Unwanted side effects. As we move towards the quantum era, however, there can also be some unfavorable side effects that need to be taken into consideration. The possibility that future quantum computers would have such tremendous computation capabilities raises serious security concerns, since they could be used to circumvent the encryption mechanisms that are currently used to protect the internet. Anyone can listen in on conversations between people when they are communicating online. They must therefore first be encrypted. Vadim Lubashevsky, a cryptographer at the IBM Research Lab in Zurich, noted that the way encryption works between two individuals who have never met is that they must rely on certain algorithms, such as RSA or elliptic curve, Diffie-Hellman, to exchange a secret key. It's bad news for our privacy, since big tech has now achieved quantum supremacy view. The difficult aspect is exchanging the secret key, and this requires certain mathematical presumptions that are no longer valid with quantum computers. Organizations and state actors should already be changing their cryptography to quantum-safe algorithms, or ones that cannot be cracked by quantum computers, according to Lubashevsky, in order to protect against this. Many of these algorithms currently exist, and others are being developed. It will undoubtedly break encryption, thus it is a drawback. However, since we can fix that, there is no reason to delay building a quantum computer. Even if we don't have a quantum computer, we can write algorithms, and we know what it will do once it exists, how it will run these algorithms, he claimed.